I'm on location in downtown San Antonio, Texas, where crews have just finished setting up this massive 650-ton crane. The counterweights are on, the outriggers are down, and the jib, an extension for the crane's telescoping boom, is being rigged up. This is the famous San Antonio Riverwalk, a city park below street level that winds around the downtown district. It's one of the biggest tourist attractions in the state.
This is pretty cool. I've actually not seen this before. I'm not too familiar with the Texas area, so I'll have to keep this in mind if I ever visit in the near future.
Connecting shops, restaurants, theaters, and Spanish missions, the most famous of them being the Alamo. Every year, millions of people come to see the sights, learn some history, and maybe even take a tour boat on the water. It's easy to enjoy the scenery without considering how it all works. But how many rivers do you know that stay at an ideal, constant level just below the banks year-round? One of the critical structures that make it all possible is due for some new gates, and it's going to be a pretty interesting challenge to replace them without draining the whole river in the process. I've partnered up with the City of San Antonio and the San Antonio River Authority to document the entire process, so you can see.
That is actually pretty cool that he's working with the local government in this project here to actually sort of do a documentary, so to speak, of the process and what they're doing here. It's cool that he has that type of access. Maybe he's more well known in this area, or at least his videos are quite popular, so maybe that was enough for him to be able to get that access.
Behind the scenes of one of my favorite places. I'm Grady, and this is Practical Construction. After a catastrophic flood in 1921 took more than 50 lives in San Antonio, the city took drastic measures to try and protect the downtown area from future storms. Back when my first book came out, I took a little tour of some of those measures, one historical, Olmos Dam, and one more modern, the flood diversion tunnel that runs below the city. But another of those projects eventually turned into one of San Antonio's crown jewels. A major bend in the river, right in the heart of downtown, was cut off, creating a more direct path for floodwaters to drain out. But rather than fill in the old meander, the city decided to keep it, recognizing its value as a park. Gates were installed at both connections, allowing the bend to be isolated from the rest of the river. Later, a dam was built downstream on the San Antonio River with 2 floodgates. During normal flows, these gates control the level upstream on the river, maintaining a constant elevation for the Great Bend and the cutoff. If a flood comes, these gates can be shut to maintain a constant level in the bend, and these gates can be opened to let the floodwaters pass downstream. Essentially, this pair of floodgates are pivotal parts of the San Antonio Riverwalk. They hold back flow during sunny weather to keep the water levels up, and they lower to release water during storms to keep downtown from being flooded. They were installed way back in 1983, and after a long life were already planned for a replacement. Then this happened. One of the floodgate's gearboxes had a nut with threads that had worn down and eventually stripped out. It caused one side of the gate to drop, damaging several components and rendering the floodgate inoperable. The city of San Antonio immediately installed stop logs upstream of the gate to block the flow.
It's good that they had been planning to repair this, but I feel like this is a common theme in a lot of areas where you have some type of infrastructure and it just doesn't get the attention that it deserves. And this has led to a number of failures, I want to say, in a number of cities. And so this is something, especially this being so key, being a touristic area, being something that helps maintain the environment for their downtown area. I would hope that more things are being done to keep this type of infrastructure that's critical up to date and up to code and in good functioning order. But unfortunately, it doesn't always happen that way. But it's good that it's getting done now, but it's curious to see that, while I'm not that familiar with Texas, but this does seem to be a recurring theme that I've seen across city areas and across the US.
And prevent the water level in the Riverwalk from dropping. But the gate is still unable to lower in the event of a flood, having the capacity of this important dam. So they sprung into action to design replacements for these old gates. It's been a long road finding a modern solution that fits within this existing structure, but it's finally time to remove the old gates and bring this dam into the 21st century. There's a lot of work to do before the broken gate can come out. The first job is just to get the water out. This dam has a place for stop logs both upstream and downstream of each gate. Historically, they'd be wood, hence the name, but modern stop logs are heavy steel beams that stack together to create a relatively watertight bulkhead on either side. These stop logs have been installed since the gate went out of service, and while they hold back a whole lot, they aren't completely watertight. Inevitably, some water gets through to fill up the area between them, making it a challenge to work in this area. The contractor has brought in a large diesel pump and perched it on the bank next to the broken gate. They get it running, and it's not long at all before the area between the upstream and downstream stop logs is dry enough to work. The first thing to go is the drive shaft between the two gate operator gearboxes. When these gates are functioning, the shaft delivers power to the opposite side of the gate and keeps both sides raising or lowering at the same rate. But now it's just in the way and needs to come out. It is disconnected, and the crane lowers it to the ground. The next piece is the support beam between the two operators. Same as before, it's detached by the crew, rigged to the crane, and lifted away from the dam. It's flown across the site to the staging area and set down. All this equipment will eventually be hauled away and recycled for scrap. It might be obvious, but even though it's broken, this gate is still attached to the rest of the dam. At the bottom with hinges and at the top with the two stems that would raise and lower the leaf when it was working. Before the crew can detach the gate, it will need some additional support. The crane lowers its hook, and the crew wraps two massive chain slings around it. Then the crane cables up to provide support for the gate while it gets detached. It's not easy doing big projects like this in the downtown core of a major city. The River Authority has had to lease the parking lot next door for a place to put the crane and other equipment. There are strict rules about when they can work to make sure the project doesn't cause too much disturbance to all the neighbors. And this is part of the Riverwalk, which means it's a heavily trafficked pedestrian route. The contract.
It's interesting that he has mentioned that the city had to rent out space to be able to maintain this area. It seems like they should have maybe retained some land rights to the area around the river to enable things like regular maintenance, especially at these choke points like these gates here. It's an interesting process and a concept to think how our governments have to still pay like citizens to get their work done sometimes, and how that could potentially lead to some inefficiencies. But it's curious to actually see it in action, that they were in this situation to begin with, and that there aren't any rules, regulations that say like they can just go in and kind of use that space for repairing this. Or interesting also that they chose to basically rent out this space for this parking lot to be able to do this work instead of potentially, there seems to be a road. It's hard to tell. This might be a bridge of some sort here, so that might be too high. But it's also curious that they presumably would have owned some of the land, some of the roads or something like that, that they could have put this equipment on as well, and maybe just like closed off one of the roads for the duration of this project in order to get it done.
Has to set up barricades during work hours and then take them down at the end of each day. They also have safety spotters who make sure there are no wayward pedestrians or workers within the swing of the crane during heavy lifts. If you've worked on a device or turned a wrench, you've probably been faced with a stuck bolt before. But what do you do if the bolt is as big around as your arm? Pretty much the same thing you do at a smaller scale. Apply some penetrating oil, beat it with a hammer, bring out a hydraulic press, and then you just decide to cut the whole thing off. This gate's being scrapped anyway, so there's no use treating it with kid gloves. The crew gets out the oxyacetylene torch to cut the ears off the top. First one, and then the other. Next come the hinge pins that connect the gate at the bottom. A few come out pretty easy. A few take a little extra effort. With a chain hoist pulling, the hydraulic toe jack pushing, and a little percussive persuasion, the crew eventually gets them all out. Just cutting and hammering and pushing and pulling all the connections this gate has to the dam is an entire day's work. These are big, heavy items in awkward positions, so each time they move, disconnect, or lift something out of the work area, they have to do it thoughtfully and carefully to ensure it's done safely. By the end of the day, the gate is finally free, but the crew decides to set it down and wait until tomorrow for the critical operation of lifting it out. The next morning, it's time for the big lift. The chain slings are re-secured around the gate, and the crane reaches over the trees and river to slowly remove it from the dam. It's a big moment, so the whole crew gathers around to watch. Safety spotters coordinate with the crane operator to pull the gate free from the dam, then hoist it up and over. Safety personnel are also making sure that no one wanders into the area, but just in case, a horn sounds whenever the load is over the sidewalk. Eventually, the gate makes it to the staging area. And
maybe it was based off of his distance, but that seemed like a very light horn that they were using to potentially warn of somebody's potential doom if this gate were to hit them or to fall onto them. It seems like they should have gotten a little bit louder of a horn to make sure folks were aware and there was no mistake there. But it was just a comical, almost like cartoon-esque small horn that seems to be used for this project.
In the parking lot, on dry ground for the first time in 40 years. It did its job admirably. It was a great gate, but it's easy to see from its condition that it was definitely time for retirement.
So now that they've gotten that gate removed, something that he mentioned is that they were looking to modernize this gate, which is curious. They haven't really started on anything else since obviously they just got the gate out at that exact moment in time. But it doesn't appear as though they're really planning to shift this structure to something else entirely. It looks like they would have a very similar gate that goes up and down at sort of this angled ramp that they have. So it can go up and close and then down kind of diagonally until eventually is 90 degrees all the way. And so I'm curious what he meant by modernizing here, because it seems like you'd require most of the same mechanisms. It doesn't seem as though they're going to be doing any new techniques here. I would imagine based off of the current structure that is around it and the fact that they don't appear to be trying to remove the second gate to the left of this area, which you will be able to see here when I move. So you can see kind of it towards the middle of the screen. That's where the first gate is that they just removed, and then there's the second gate to its left. And they haven't really been touching that. There's no equipment next to it or anything at all. So presumably for this to continue functioning, they would have to maintain this exact structure. And so my imagination is that they would just replace it with another gate of comparable size and comparable functionality to the previous gate, at least from what we've witnessed so far. Again, because I would expect there to have to be more work done in the surrounding area to accommodate a much larger change. Like if they're going to install like multiple series of gates or something like that, or a different type of gate or a different lever or mechanism for it. Likely the segments and technology that they're going to use for moving the gate, etc., would be more modern. But I wouldn't necessarily know if I would call that modernization, but maybe you all can share your thoughts on it. I would assume this is basically just a replacement of a gate. This is like if you have an old car and an accident happens and your door is broken, you get a new door. It's not like you have a new car. It's not like the car is fundamentally safer to drive compared to what it was when it was in functioning condition compared to like newer, more modern vehicles. So we'll see if they do actually make some more sizable changes here, but curious to see what he meant by modernization.
Gate out, a boom lift is lowered into the area to help remove some of the remaining pieces. Most of the day is spent cutting and removing pieces of the gate and attachment hardware. At this point, the area will mostly sit idle while the new gate is being fabricated. But there's more work to do in the meantime. Another part of the project is the nearby pump room. The flows in the San Antonio River often drop to a mere trickle, and this is something the city designed for when these gates were installed back in the 80s. With these gates keeping the water up at a constant level, the Riverwalk works kind of like a bathtub. It takes a big volume of water to fill up the channel that snakes around downtown. But if the water leaves the Riverwalk faster than it can be replenished, that level will drop, kind of like trying to fill a bathtub without stopping up the drain. So this dam was designed with a pump to lift water from downstream into the channel above if needed. This is a screw pump, one of the oldest and simplest hydraulic machines, sometimes called an Archimedes screw. A motor turns a steel cylinder with a screw inside. As the screw rotates, water is lifted upwards until it spills out at the top. In this case, it falls into a flume that flows to the river above the dam. It's ingenious.
I'm surprised he didn't show like a diagram or something like this. I feel like from past videos that I have seen from him, he usually does these like small experimental options or maybe shows like diagrams of some sort. And so that might have been slightly confusing. So for the Archimedes screw, basically, it is sort of like what it means. Like if you have an actual screw, they sort of have that like swooshing like spiral that goes around. And so what ends up happening is that if you think of like a screw like that inside of a pipe that is basically just the exact size of that surrounding swirl, then effectively you get sort of airtight segment up against the edge. Likely it isn't fully airtight, otherwise that would probably cause a lot of friction, eventually wear down. But something that's very close to that. And then as the screw turns, when you think of screwing it normally into like a piece of wood or something, it uses that swirl and that spiral formation to kind of help secure itself into the wood as it goes through, so it has something to hold onto. And so in that scenario, it's holding onto the wood, but in an Archimedes screw, basically, is holding onto the water. And so that spiral on the outside basically has water go up, and it will slowly rotate, and then the water follows the spiral upwards against gravity effectively. So it's just kind of like a fancy spiral instead of using like a bucket and like a pulley system of some sort. It will just naturally carry the water upstream. And so it's something that Archimedes invented. And so it is a common way to move water. So just a little bit more explanation there for folks who might not be familiar with it.
Yes, in its simplicity, and apparently worked great when it was first installed. But not long afterward, San Antonio built its landmark flood control tunnel that allows floodwaters to bypass downtown. It's an incredible.
So this seems to be the segment that he was referencing of modernizing it. So it seems to do less with the gate itself and more with the broader water and how you keep the level consistent for the bend in this river. So it seems like they're going to be swapping this out with some other form of pump or something else in order to keep that water up right into the correct level for the ideal leveling of this environment.
Project of its own, and it included the means to recirculate water in the San Antonio River from downstream to up. That keeps the river flowing during dry times, maintaining the level in the Riverwalk downtown, and rendering the old screw pump obsolete. So it never got turned on again and has been sitting here unused for many years. This new project is going to repurpose the area to create a bypass for the two gates. It will add a bit more capacity, but more importantly, it will help create some circulation in the stagnant area downstream of the dam. Still water allows sediment to build up, collects debris, and grows algae and mosquitoes. With the screw pump not running, this area just doesn't quite see enough water movement, so the bypass will allow it to be easily flushed out when needed. But first, the screw pump has to come out. This is the same story as the gate: oxyacetylene torches and hammers. Piece by piece, the pump is cut away and hauled off a scrap. With the pump out, the room gets some modifications. Some concrete is taken out, and new concrete is installed to create a chute for the water. And then it gets its own new gate to control the flow. Luckily, this small pump room has an overhead crane because getting this gate into place was a tight fit. Back outside, crews start working on the retrofits to the dam to get ready for the new gate. Unlike the electric motors used for the old gates, the new ones will use hydraulics. These piers that flank the gates have to be modified to fit the new system. The tops of the piers get some careful demolition to accommodate the hydraulic cylinders. And the hinges from the old gate still need to be removed. This area will also have some concrete modifications so the new gate fits perfectly in the old slot. Nearly a year after the old gate was cut out, the new gate finally arrives on site. It sounds like a long time, but this project was specifically scheduled around the fabrication of these gates. They aren't just parts you can pick up at the local hardware store. A lot of design, construction, testing, and finishing touches went into each one. And they're so big, they have to be delivered in 2 parts. Today's job is to connect them into a single gate. The halves get a layer of sealant to prevent leaks, and then a whole bunch of bolts to attach them together. And finally, this gate is ready to install. You know I love crane day. And it's even better when there's a small crane to assemble the big crane. This 650-ton capacity monster is configured with a luffing jib to reach out over the trees and water. But the first step is to get the gate off the stands. It has to be lifted horizontally from these sawhorses, but it will be installed vertically. So the gate is rigged for the first lift, moved to the ground, and then re-rigged for the main event. I'm a sucker for heavy lifts, so this was a pretty fun thing to see in person. It's incredible how much work and setup went into a milestone that only took less than an hour to complete. It's a much slower civil engineering equivalent to a rocket launch. The crane swings the gate up and over the trees and down to the dam. As it gets closer, the movements are slower and more deliberate. Each time the crane moves, the crew waits for the massive gate to stabilize before calling for the next step. They carefully move it into position, and when everything is lined up just right, it sits down on the base plates, ready to be connected.
Seems to be really milking this gate movement here. I feel like we've seen this like 4 or 5 times now.
While it's held by the crane, the crews begin installing the bolts that attach the gate to the concrete. This is allowed by safety regulations, but only under a set of rigid guidelines, so safety is at the top of everyone's mind. A detailed lift plan, a pre-work safety briefing, and several spotters make sure there are no wrong moves. These bolts are torqued to the specifications one by one on both the upstream and downstream side of the gate. And once it's firmly attached, the crane lowers it to the ground. The next day, the beam across the top of the piers and the hydraulic cylinders are flown into place. These cylinders will lift and lower the gate, working against the immense water pressure pushing on the upstream face. They'll attach to these beefy hinge points on each side of the gate. The cylinders are attached to a new hydraulic power unit installed in the pump room. This unit has the valves, pressure regulators, pump, and oil reservoir to make these gates operate more efficiently and reliably than the old electric motors did. Everything is operated from the city's tower that overlooks the dam. From here, operators can control all the city's flood infrastructure, including the dams and gates on the river and the flood bypass tunnels that run below ground. And I have to say, it's a pretty nice view from the top. And in fact, some of the time-lapse clips that I've shown are from a camera mounted on top of this structure. This is run by the US Geological Survey, and I'll put a link below where you can go check out the dam in real time. Once everything is hooked up, it's time to test this gate out. Unfortunately, you can't schedule a flood. Since there are just ordinary flows at the moment, the crews have to be careful not to drain the entire river walk while they do it. The gate gets lowered just a bit to make sure nothing is binding and that the hydraulic system is working. Of course, it's a big day to see it all working for the first time, so everyone involved in the project is on site to see it happen. And the test went flawlessly, but it's not the end of the project. These stop logs were installed in early 2021, and it's finally time to pull them out nearly 4 years later. You can see they grew some nice foliage during their service. This process requires a professional diver to rig each one for the crane. It's just one of the many steps made much more complicated because this structure still has to serve its purpose during the entirety of the project. And more importantly, the Riverwalk can't be drained. The stop logs get lifted out of the slots, then they're moved directly next door to get ready for the next gate. I didn't document as much of the second gate because it was pretty much identical to the first one, although it went a lot faster since the gate was already ready. The area was pumped out, the old gate removed, and the new one lifted into place. And pretty soon this old dam had 2 new gates, plus a bypass, ready to serve the city for the next several decades.
It's nice to see that they actually replaced the other gate as well, because that's where a problem could arise, is if they are on different mechanisms, and also if the first gate failed, then likely the second one was going to follow shortly. So it's nice to see. And also I'm sure it will look much cooler if they have matching gates.
If you visited the Riverwalk during construction, you wouldn't have even known it was happening. And that was the entire goal of the project, to revitalize a critical part of the city's flood control infrastructure without causing any negative impacts on one of its crown jewels.
That's a good point that he's bringing up, which is a lot of this work on infrastructure. I even complained about it earlier at the start of this video of some of the infrastructure failures, but it is potentially one of those like thankless jobs of, if they do it right, nobody notices and everything just functions the way it is. And then if it breaks, then it's very obvious and then people will complain. So kudos to the people who are involved in this and do this type of work on a regular basis. I'm sure you probably don't get the thanks or praise that is deserved of helping cities maintain their function and keep people safe. But it's cool to get this seen, and it's cool to think about how governments and these agencies and whoever else is working on these types of projects spend a lot of time to minimize their impact to individuals. I'm sure, having seen construction myself, obviously they do sometimes close roads or bridges or whatever it is, and I'm sure oftentimes people will complain about that inconvenience, but probably not thinking so much about how much thought and effort went into trying to minimize that negative impact for people, for their commutes or for their daily life. So I think that was a cool part that he added there, and I think that's one of the things I appreciate most about these videos, is that he really focuses in on engineering in the real world. Again, being a software engineer by trade myself, I mostly deal in theoretical things. At best, this software gets run on a piece of hardware and then you can see it do what it's doing, but the hardware piece is still separate from most of what I focus in on as my main profession. And so thinking about how engineering works in the real world for physical things like infrastructure is really cool to take a moment and appreciate the work and thought that goes into it, since I spend so much time thinking about a virtual digital world. Maybe even for yourself, you might not be a software engineer, or maybe you don't have that type of job or background, but I suspect that for many of us, this is something that is sight unseen, and we just don't pay that much attention to it. We just assume it works and go about our days. And so I think it's really cool to take a moment, see how some of this stuff works, understand a little bit more about the effort and the engineering that goes behind these types of projects.
Tools. And being on site to see it all happen in real time was a lot of fun. I have to give a huge thanks to the City of San Antonio, the San Antonio River Authority, the engineer, Friesa Nichols, and the general contractor, Guido, and all their subcontractors for inviting me to be a part of this project and document it for you.
Thank you for watching. If you've enjoyed what you've seen, please hit like or subscribe. I will see you around.